All right, let's talk about XPath. So XPath is kind of the equivalent of the SQL language, right? That allows you to provide select statements, right? That allow you to retrieve data from certain tables and provide some criteria by which you want to retrieve those records, right? And in here, those records are represented as nodes, right? In a tree that can exist, downstream or can exist upstream, and those can also contain either values, ASCII text values, or they can have attributes that have certain values, and those values could be in dates, it could be integers, could be strings, could be some regular expression. And so XPath is a language that allows you to query, right, to refer to different portions of the document that meet a certain criteria, right? Whereas in SQL, you use it to choose which tables you want to incorporate in your query, and then decide which columns you want and which rows you want, with using projections and the where clause and the from and whatnot. XPath also allows you to refer to different portions of the document in the XML document. You might not want the entire document. You only want a subset of the documents, right? Only those elements, only those nodes and certain branches, right, that match a particular criteria. Okay. Okay. So yeah, we saw earlier a couple examples, right, that allowed us to navigate downstream to nodes that were our children, right, or navigate upstream, right, up to nodes that were our parents, right? So we already saw a couple examples of that in the select clause here, right? And so the language has its own set of tokens, right, that allow you to either refer to a particular element by its node name, or refer to a particular path as element, right? Refer to the current location or the previous location in your parent, right? Or refer to an attribute inside of a particular element. So here's a couple examples that we are referring to. All the nodes who have a particular name, so bookstore all by itself as a string, select bookstore. That means that, hey, find me all elements who have this name, no matter where they are in the node, in the tree, right? Or you can be a little more specific and say, well, no, I only want the node bookstore, but from a particular from the root of the tree, right? So I don't want you to look for everywhere in the tree, only the ones that are at the top of the node of the root. Or you want to find a book who has a parent called bookstore, so it'll do a pattern match anywhere in the tree, trying to find this match. Only those nodes that are of whose name is book, but are under a parent who are bookstore. Anywhere / or if you have anywhere, there could be a book, and between bookstore and book, there might be other elements that you want to ignore, right? So you just want to say, well, find me all the bookstore, no matter what, but they have to begin with bookstore there, right? Or find me an attribute that has a name called lang. Also, if you have multiple elements that match your criteria, you can refer to indices. You can refer to the first element that matched, or the last element that matched, or the third, or the fifth, right? You can refer to by using operators such as last, position, right? Or you can have a numeral, or you can also find elements that have a particular attribute, at lang, or that have a particular value, then an attribute has a value. So only find me those books who have a title whose language is English, right? Or find me all the books whose price is greater than 35, right? That has a specific title. So there is the capability of providing like the where clause, right, of a select statement that allows you to identify the specific nodes in the document that match a specific criteria. So XSLT, as we saw earlier, can be used to transform or restructure an XML document as an incoming document and convert it brand new documents. And XPath allows us to refer to all the elements that are being transformed. So let's take an example of transforming, for instance, something that might be very normalized on the left-hand side, convert it into something that is more denormalized on the right-hand side, okay? So left to right. So the left-hand side might be very hierarchical, right? Split up into multiple elements, right? Nested inside of each other. But, we might need to send it over to the registrar's office, and the registrar's office just needs to know who's enrolled in 2018, right? And the courses that we're taking in that particular enrollment, right? So let's do that transformation. So here's the incoming input document that has students and has courses embedded inside of those students. Let's try to flatten this, right? So let's see. So here it is. So here where we find graduating students, right? We're generating enrollments, and then we're going to navigate inside of all the courses, inside of all the students and the courses and the course inside of the graduation students. Right? So that's easy, right? We did this already. We're going to iterate over that course. Here's a template that matches, and we're going to generate a course taken. We'll need to navigate up to go fetch the student name, right, inside of the course that we're iterating over. Also, the graduation year is also way up at the student, right? So we'll grab that as well. And for the course, we'll just grab the title, the year taken, and the grade, right? And then that's what gets generated for the course taken, okay? And indeed, it generates that, what we expected. Now, much more challenging is to go the other way around, right? What if we want to have something that is, very flat on the left-hand side? It's fairly denormalized, right? But we want to generate a more normalized version on the right-hand side. So that's much more challenging. So let's take a look at that. So here's the input, right? We have a denormalized representation. Notice that all the graduation years are all the same, 2009, right? So presumably this is all the folks that were enrolled in that particular year. There's the first one we had, way at the beginning of the lecture, right? Perhaps we want to, send it over and store it for permanent storage, but we want to normalize it first, right? So how do we do that? All right, so what we're going to do here is that we're going to first pattern match the enrollments. And for the enrollments, so we'll just do from root to root, right? So the enrollments is the root of the incoming XML document, and the output is the graduating students as the output, right? And what we're going to do is that we're going to grab the course taken. We're just going to iterate over that. We're just going to do a plain for each, right? But notice that we're not just going to do a for each. We're going to use another one that's called for each group, okay? And by group, we mean that as we iterate over the course taken, there might be courses that have the same name. Just like me as I'm taking databases, and you're also taking databases, same course, right? So we want to make sure that gets represented only once, right? So what we're going to do that is that as we iterate over course taken, we're going to group by the student name, right? Here we're going to say, I want to look at, there's going to be tons and tons of courses, right? But I want to make sure that the ones that Ian took, that belongs to a particular group, and the ones that Bob took, that belongs to a different group, right? To make sure that I can then put them under the right student, right, in the resulting document, right? So we can group by the student name, and student name is an attribute in the course taken, right? That's what we generated, right? Remember, there it is, S name, right? S name, Ian, Bob, Ben, and whatnot. So there's going to be two groups in this case, Ian and Ben, right? So there's going to be one student for Ian and one student for Ben. So basically what we're going to try to do is that for each group, we're going to generate one student, right? So one group for Ian will generate one student, and then Ben it'll be a separate group. It will generate another student. So two students in the output. Okay. All right. Excellent. So as we iterate through the course taken, we're going to generate the student. There it is. So there's the student name that we're just going to copy over the student name from the S name attribute, and for the year we're going to copy over the graduation year attribute, right? We're gonna put it inside of the elements S name and grad year elements. For the courses, For the courses, we're going to iterate. And it says, okay, well, all the courses that are in the same group, right, that are grouped by the student name, right, I want to iterate over all those courses that match, for the same student name, right? So we're assuming that the student name is a primary key, and it's unique. And so we can say here, I'm going to iterate over what, all the current group that it was generated that was grouped by the student name, Ian, yes, or Ben. So as I iterate, I'm going to generate a course instance so all, if there were 3 or 4 courses for Ian, there'll be 4 instances of this course generated for Ian, right? And it's going to extract the title, the year taken, and the grade for the course that was in that group, right? For the same group. And then it's going to generate a completely different course for Ben, right? Because that will belong to a different group. Okay, so very, very powerful that allows you to group, just like you would perhaps group in relational databases, right? But here it allows you to group nodes that belong by a particular attribute in this case, right? And close the for each group. So referencing attributes, as we saw earlier, right? We use the @ sign that allows us to retrieve or grab a particular attribute and get the value of that attribute, whatever's in the double quotes. And also it can be used for grouping, right? That we can refer to a student name as the attribute, right? It can be used in the group by to group all the elements in that group.